drew four force diagrams.
Hands up for Ryan, please.
Two for the cart and two for the bob when it was
Take out your work, make
at
notes
rest,
based on what Ryan's doing, please.
and when it was moving. So yes, first for the cart at rest. Cart has two forces going up and down. It's the force of the earth on the cart and the force of the floor on the cart, I guess. And then it has two forces going to the left and the right. And the force trying to take it this way is the force of the string on the cart. And then the one holding it back would be the force of the hand on cart. And you can draw your axis. X, bottom, bottom. And that's for the cart at rest. But after the hand's taken away when it's moving, you still got these two forces. Force of earth on cart, the cart. Force of the floor on the cart. And you don't have this force anymore, the hand on it. You only have this force, the force of the string on cart. That's why it's going to move and accelerate to the right, or in the positive direction. And we have to draw two for the bob. The bob is the object of interest. It has the force of the earth on the bob. It has force string on bob.
Is this when it's moving or when it's staying still?
This is when it's still.
Okay.
And it doesn't have any forces going left and right. So that one's done. And then when it's moving, you just have the force of the earth on bob. There's the bob. And the hand's not there anymore. And it's moving down, it's accelerating downwards, so it has a delta V going down. So this arrow is going to be shorter, the force of the string on the bob. This one's done. Thing is that Newton's third law, where the force of the string, it's the same on both objects because they're both interacting with the string. So I guess here, I'm gonna mess it up, but that arrow has to be the same length as that arrow. Because of Newton's third law. So you see between this one and this one, the arrow got shorter, so it got less.
So what would the scale look like?
It would like go down. It would be less.
Anybody have any question for Ryan's work? We're not telling you it's right yet, but I want you to please evaluate his reasoning, which means you have to understand his reasoning. So if you don't get it yet, ask him.
Just, can you explain one more time how you knew that in the second diagram for the bob, that arrow was smaller?
Because the bob starts falling, when it's moving, so it's accelerating downward. So the delta V has to be down, so the force of the earth on the bob has to be greater than the force of the string on the bob.
I have a question after Pete.
Why'd you make the force of the string on cart like smaller between the two graphs?
Because it has to be the force of the string, since these are like interacting together, this like Newton's third law, the force of one has to be the same as the force on the other. So the force of the string while it's in motion is going to be the same on both objects.
How did you know that the force of the string on the bob didn't just go away, go to nothing?
I considered it, but I don't know. It was like because the string's still touching it, so it's still interacting with it. So there has to be like some force there between two objects that are interacting.
Crystal?
Oh no, that's what I was gonna say. That's what you said.
I don't know, I could imagine touching it very, very lightly, so that the force is essentially zero. Can anybody tell me why the force can't be zero of the string on the bob?
Nope.
Because
Alex?
Because they're both like things that the bob and the cart are accelerating, so if there was no force, no one would be accelerating.
if there was no force of the string on the bob, then the cart wouldn't be moving.
Awesome, because if, yes, may I explain the step in between for the benefit of the rest of us. No force of string on bob means,
No force of string on cart.
that's right, and that can't be the case because the cart's accelerating. Good job, Alex, and everybody, Chip. Brian, that's awesome. That's a really hard problem that you came up with all by yourself. That's super. Now, what of